Dimensional quantities. What is this topic all about? Before we can get to know about this, we need to understand what fundamental and derived quantities are. We also need to understand how derived quantities relate to fundamental quantities. I'll be back, and don't forget to like, comment and share. What do we refer to as fundamental quantities? They are literally the basic unit of measure. To understand it more, they are the smallest unit of measure that cannot be further broken down, and are usually used to create other measurement scales, which are known as derived quantities. Fundamental units are such as time, in seconds; length, in meters; mass, in kilograms, and so on. Now we can move to our topic of the day, which is dimensional quantities. It is mostly elaborating the relationship between fundamental quantities and derived quantities. That is the relationship between the units m, l, t, a, and so on. Let me make a quick example with the quantity, velocity. Velocity, as we know it, is defined, displacement per unit time. Expressed as velocity, v, is equal distance, s or x, divided by time, t. That is v equal s divided by t. Now we relate our units with the fundamentals known as mass, length, and time. We know that the unit of distance is in meters, and same with length, so it would be replaced by length, l, and we can also find time, t, in the equation, so it would be solved as velocity is equal L over t. Now for you to know this next part, you need to know a little bit of indices. There's this law of indices that states that 1 over x is the same as x raised to power minus 1, and 1 over x squared is same ax raised to power minus 2, and so on. So we apply this law to our equation of L over t. You would agree with me when I say that it is the same as L, t raised to power minus 1. For better understanding, L over t is same as L multiplied by 1 over t, so we can apply the rule of indices I gave last time, which will lead to L multiplied by t raised to power minus 1, which results to L, t raised to power minus 1. Now that is how velocity relates to the fundamental quantities. You can apply the same method for acceleration, pressure, force, and many more derived quantities. Take for example acceleration. Acceleration is equal velocity over time, but velocity is still a derived quantity waiting to be broken down, so we break it down to distance over time, which is still divided by the main time at the denominator. So when you relate them to the fundamental quantities, you get L over t all over t, which will eventually result as L, t raised to power of minus 2. So now you get the idea of what dimensional quantities is all about. I'm going to stop here for today. And if you enjoyed today's video, don't forget to subscribe.